Good morning, everyone. Welcome to Math Mondays. I'm Kayla Barnes, Math Coordinator for Kansas City Public Schools, and the segment that follows is kindergarten through second grade math. Hi friends, how are you doing today? This morning we are going to build on our knowledge that we started working on last week in regards to place value. So this week we are going to have a very focused lesson that stems from place value and goes into comparing numbers. So our objective today is I can determine 1 more, 1 less, 10 more, and 10 less than any number. So by the end of this lesson today, you should be able to think of any number and be able to tell me what is 10 more than that number, what is 10 less than that number, what is 1 more than that number, and what is 1 less than that number. Our tools today, we're going to be working with 2 different tools, base 10 blocks, which we started working with last week, and today we will also be using a hundreds chart in order to see some patterns in our observations. As you're working with me today, the only thing that you need is a piece of paper and something to write with, and then it's always important to have something near you that you can that you can utilize to help you count with. So I would recommend those 3 things. Take a moment now and let's get ready to learn. All right, so our first problem today, we're just going to pause here and I'm going to show you everything that is on the screen in front of you. That way, as we get working, you don't have any questions about what I'm grabbing or the format in which I'm presenting. So over here on the right in the blue section, you'll see my tools for today. I told you we'd be using a hundreds chart, so there's a hundreds chart. And we'll also be using base 10 blocks. So here's a tens rod, and here's a ones square in this case. So the first thing we are going to do is we are going to talk about the number that you see on your screen in the gray box. And the first number that we're going to start with today is the number 37. Okay? So as we're determining more and less than a number, the first thing I'd like us to do on this problem is model 37 using base 10 blocks. Do you remember how to do that? Here's a quick review. So as we look at the number, we think 30 and 7. So I'm just going to write that down. So I said 30 and 7. That makes 37, right? So remember that when we're talking about the number 30, that's the number of ones is that we will see in that number. But how do we take base 10 blocks and model 30 plus 7? So in order to model 7's easy, right? We're just going to take 7 ones squares in this case, and we're just going to put them here. So there's 4, 5, 6, and 7. Great. Now I don't want to drag 30 individual blocks underneath the number 30. What's a different way I can model 30 using the base 10 blocks we have on hand? That's right. Remember that 1 rod equals 10. How many tens is in the number 30? Well, here's 10. Let's add another one and see if you can count by tens here until we get to 30. So here's 10, 20, and 30. Great job. So the number 37 is made up of 3 tens and 7 ones. And we've modeled it below using the base 10 blocks. Now what we have to do is calculate 1 more, 1 less, 10 more, and 10 less. So we're going to take that one step at a time. And on the left side of your screen here, you're going to see that I'm starting with 1 more than 37. Using our base 10 blocks, how can you model 1 more than 37? What would you add? A rod or a unit square? That's right. Let's use a unit square. So if we add 1 more to 37, add 1, what do we get? Well, 30 plus 7 we know is 37. Count on 37 one more time and we get 38. Good job. So I'm going to erase this part because now we need to talk about 10 more than 37. So I'll fix this block here and put it back. And now let's talk about 10 more than 37. So we added a 1's unit square to get 1 more than. Let's add a 10's rod to get 10 more than. So now we have 30 plus 7 plus 10 gets us to 10 more than 37. Well, what's 30 plus 10? That's right, you know 3 plus 1 equals 4. So 30, 3 10s, plus 10, 1 10, equals 4 10s, or 40. Good job. So we have 40, and then we have to add the 7 1s. That gets us 47. Great job. Now we have to talk about 1 less than. So we need to erase drawings first and put materials back that we don't need. When we talk about less than, are we adding or subtracting? Which one? That's right. When we talk about a number being less than, we're typically subtracting. So when we talk about 1 less, we're going to take 1 away from 37. That means down here with the unit squares, I'm going to take 1, I'm just going to put it off to the side, that way I know I've taken it away. We started with 37, and if you take 1 more away, that gets us how many? Good job, that gets us 36. And last but not least, the last thing we have to do, let's put this block back so that we get 37. Let's erase the -1. Now we have to calculate 10 less than. So when we were calculating 1 less, we took 1 unit square away. Now we're calculating 10 less. So what are we going to take away? That's right, let's take away 1 10's rod, or 1 10, because we know that 1 10 is equal to 10 1s. Now we have 30 plus 7, and we took away 10. What is the answer to this problem? 10 less than 37 is equal to what number? Well, 30 minus 10 is 20, plus 7 is 27. You did a great job on that problem. I know there were a lot of steps. Now we're going to move on to the second problem, where we're going to use a hundreds chart to see if we can draw some patterns and how we can do this quicker. So let's talk about the second problem. The second number we have is 72, and we have to calculate 1 more than, 10 more than, 1 less than, and 10 less than 72. And this time I'm going to use a hundreds chart. So I'm going to make it a little bigger so that it's easier for us to use. There. Now, the first thing that I'm going to do when I utilize my hundreds chart is I want to highlight the spot or the square where the number that we start with is. So I'm going to take my yellow highlighter here, and on the hundreds chart I'm going to find 72. And I'm looking down to where I see 70s, and then I'm going over 1, 2, and right there is number 72. Now, when we're calculating one more than, let's back up actually. Let's start back. Can you tell me how many tens and ones is in this number? Because we have to start there in order for this to make it easy for us. So when we model 72, you can build it with your base 10 blocks. You're going to find that you have 7 tens and 2 ones. Remember, the number on the left of a 2-digit number will always be the tens, and the number on the right will always be the ones. So we've highlighted 72 on our hundreds chart. Now we can talk about 1 more than, 10 more than, 1 less than, and 10 less than. So when we're talking about 1 more than, we need to take 72 and add 1 to it. On the hundreds chart, can you tell which direction I should move? Should I move to the right? Should I move to the left? Should I move up, or should I move down? Which direction will give us 1 more than 72? That's right, we know that 1 more than 72 is 73. And I can find that on my hundreds chart by moving 1 spot to the right. Now, if we're going to talk about 1 less than, we're going to skip 10 more for right now. We're going to talk about 1 less than 72. Take 1 away from 72 and you get 70. Let me undo that, change my marker. And you get 71. Now look at our hundreds chart. Which direction do we have to move in order to get to 71? To the left, up, down, or to the right? Well, we already had 73 to the right, so we know that 71 is going to be on the left. Great job. There's 2 more for us to do. Let's go up to 10 more than 72. So if you think really hard and add 10 to 72, you can do 72 plus 10, or we do know that 70 is 7 tens, and then 1 10. How many tens do you get? That's right, you get 8 tens. So if we take 70 plus 10, we get 82. Now look at your hundreds chart. Where do you see 82? Above or below 72? That's right, you see it below. Now the last step is to calculate 10 less than 72. That's your job today and this week. And I want you to keep practicing as hard as you can. And I hope that you have a great Thanksgiving and a great fall break. And I will see you after. It was my pleasure having you in class today. See you next week.
Hi, KCPS. Today, you're going to be working with me, Miss Dorsey again, and we're going to be solving multi-step problems. Have you ever gotten to a word problem in math class and you can't just solve it with the information that's there? Sometimes you need to do more than one thing before you get to your answer, and that's what we're going to practice today. Come along with me and let's take a look at our problems. Let's take a look at our first problem. There are 9 girls and 4 adults in Amy's scout troop. How much did the troop pay for tickets to the amusement park? I know that this problem doesn't give me enough information to help solve that. But do you see something on the page that will help us? That's right. If you are talking about this data table here, you are on the right track. This data table is going to help us solve our problem and give us the necessary information to do all the math. Let's go back to our problem and look for some information that we're going to need. Do you see anything that stands out at you? Absolutely. We need to know how many people there are. It says there are 9 girls and 4 adults. Do you see anything else we'll need? That's right. The question is so important. We want to know, how much did the troupe pay for tickets to the amusement park? Now that brings me back to our data table. If you look at the data table, there are 3 different plans. Now, according to our problem, which plan are we going to use for our calculations? That's right. Plan B, the amusement park, and that's right in the middle. So let's start working this problem out. I know that I have 9 girls, and according to this table, each girl costs $30. Oops, not girls. I made a mistake. Let me erase that. Each girl cost $30. Now I also have another group of people that I need to account for, and that's the adults. There are 4 adults, and according to the data table, each one of the adult tickets cost $40. So that means that I have groups of tickets. Let's take a look at this. I have 9 groups of how many? That's right, 30. And I can represent that as a multiplication problem. 9 groups of 30 is going to give me the total amount spent on the girls' tickets. I can solve this multiple ways. If I think back to number bonds, I know that there are 3 tens that make up 30. If 3 tens make up 30, I'm going to represent it this way. 10 plus 10 plus 10 gets me 30. That means that I have to multiply this 9 by each of those tens. So I have 9 times 10 plus 9 times 10 plus 9 times 10. 9 times 10 is 90. And since the multiplication problem is the same, I know that I have 90 plus 90 plus 90. If I add that up, I get 270. So 9 groups of 30 gets me 270. I'm going to notate that up here. The girls cost $270 for their tickets. Well, now I'm going to go and solve for the adults. I'm going to use the same method or strategy. I have 4 adults, and each of the adult tickets cost $40. So I have 4 groups of 40. That's going to give me my total amount for the adults. I can do the same thing I did above and create a number bond for 40. If I want to take out groups of 10, since those are easy to multiply by, how many groups of 10 are there in 40? 10, 20, 30, 40. There are 4. So that means my number bond must have 4 pieces. So there are my 10s. I know that each of these 10s must be multiplied by 4. So that's going to leave me with 4 times 10 plus 4 times 10 plus 4 times 10 plus 4 times 10. What is 4 groups of 10, or 4 times 10? That's right, it is 40. So I know I have 40 plus 40 plus 40 plus 40. If I add those together, that's going to give me my total. 40 plus 40 is 80. 80 plus 40 is 120. 120 plus 40 equals 160. That tells me that the cost for the adults equals $160. So now I have two amounts, and I need to figure out how much money it cost total for the troop to go to the amusement park. What can I do with those two amounts to help me find my answer? That's right, I can add them. I'm going to add the total for the girls and the total for the adults. Now I want to keep my work precise, so I'm going to come up here to the top of my board and I'm going to go ahead and add those. So I have $270 for the girls plus $160 for the adults. 0 plus 0 is 0. 7 plus 6 is 13. I put my ones digit down and I carry my 10. 2 plus 1 is 3. Plus what I carried is 4, which really stands for 400. How much money did I spend, or I'm sorry, how much money did Amy's Scout Troop spend on the amusement park tickets? $430. So the answer to this problem is Amy's Scout Troop spent $430 on the amusement park tickets. Great job. Now let's take a look at a different problem. Tina visited Funland with her mom and a friend. They bought tickets for Plan C. How much money did they save on the 2 children's tickets for Plan C instead of buying separate tickets for Plan A and Plan B? There's a lot of information in this problem. Let's go back and take an additional look. So we know that Tina went with her mom and a friend. They bought tickets for Plan C. The problem is asking something a little different than the first one. How much money did they save on 2 children's tickets for Plan C instead of buying separate for A and B? So Tina went with her mom and a friend, 1 adult, 2 kids. In this problem, do I need to worry about the cost of the adult ticket? No, I do not. I am just going to be comparing the prices for 2 children's tickets. So let's start to set that up. So I know that I'm going to have Plan A, Plan B, and Plan C. And I have Tina and her friend. I'm going to need to figure out first how much money they spent on Plan C for 2 children's tickets. So I'm going to go back to my data table and take a look at Plan C. According to the data table, how much is each child's ticket? $40. So for Plan C, I know Tina's was $40 and the friend's was $40. If I want to know how much that was together, what am I going to do to those two amounts? That's right, I'm going to add them. So 40 plus 40 will give me $80. So they spent $80 for the two children's tickets under Plan C. Well, now let's figure out how much the tickets cost under each of the other plans. Go back to the data table. How much does each child ticket cost under Plan A? $20. Very good. So I know that Tina's ticket costs $20 and the friend's ticket also costs $20. How much is that altogether? That's right, $40. So Plan A costs $40 for two kids. Now finally, let's take a look at Plan B. According to the data table, how much does each children's ticket cost? $30. Tina's ticket costs $30 and the friend's ticket costs $30. Altogether, how much money is that? Very good, $60. So let's go back to our question now that we know how much the tickets cost under each plan. How much money did they save? That's going to be a key word. How much money did they save on the two children's tickets for Plan C instead of buying separate tickets for Plan A and B? Okay, well, we know that Plan C cost $80. We also know that Plan A was $40 and Plan B was $60. If I want to know combined what Plan A and Plan B cost together, I need to add those two. 40 plus 60, Plan A and B equals $40 plus $60. And that equals what? $100. Is that more or less than what they paid for Plan C? That's right, that is less money. Well, let's figure out how much less, like the question asks. How am I going to do that? If you're thinking subtraction, you are right. If I know that Plan A and B cost $100 and I only paid $80 under Plan C, I'm going to subtract them to find the difference. $100 minus $80 is what? $20. So that means that they saved $20. Holy cow, you guys worked so hard today. There were so many steps in these problems, but you persevered, you stayed with me, and we solved them. See, math isn't that hard when you stay organized, you go in order, you follow the steps, and you think about numbers. You can make anything make sense by just thinking about these numbers. Great job on these problems.
Hello, my name is Mary Jo Fender and this is Math for Middle School. What we're going to go over today is what do points on a graph really mean? What you'll need for today is paper and pencil. Okay, let's take a quick second. Let's get ready to learn. Last week, we talked about what are the characteristics of a proportional relationship on a graph. And I have the two graphs from, let's review from last week. And you'll notice the two characteristics are it has to start at the origin or go through the origin, depending on if our coordinate plane just has quadrant 1 or if it has quadrants 2, 3, and 4. So keep that in mind. That's kind of special when we're looking at just quadrant 1 or we're looking at all 4 quadrants. and it also must form a straight line. Now, be careful. There are some graphs that do look like a straight line, but their increments may be slightly off, and so it gives the illusion. So you might want to check that. In our second graph, you'll notice it doesn't start at 0, 0. It starts at 20. And that can tell us something very specific about a graph, and we'll discuss that in just a minute. So let's get started. What do points on a graph really mean? So you'll notice that we have our 4-quadrant graph in the corner. At the top right, we have quadrant 1, and it goes counterclockwise, quadrant 1, 2, 3, and 4. When we're working primarily in 7th grade right now with proportional relationships, we're only going to be looking at quadrant 1 because both of our numbers or our values are going to be positive. And quadrant 1, the x value and the y value are both positive. You'll also notice that in quadrant 1, our x is horizontal. Okay, this is for all quadrants, just not quadrant 1. And our y is vertical. Okay? Now, that tells us something about our points. When we look at that graph, we'll use our point 2, 4. We have a proportional relationship between the number 2 and the number 4. Now, I used Halloween as our example because it's coming up shortly. And you'll notice as I look at my graph, I'm going to go over 2, and that means I'm going to visit 2 houses. And then I'm going to go up 4, meaning each of those houses is going to provide a total of 4 candy. Now, or 4 pieces of candy. Now we'll need to remember our equation for constant of proportionality. Remember that equation is k is equal to y divided by x. And we're going to need to understand what is the amount or quantity and what is that label or what is that unit referring to for each of those numbers. And to get that, we're going to look at our axes, our labels on those particular axes. And you'll notice the y is vertical, so that is going to be the pieces of candy. The y, if you look at its label, is going to be the houses visited, or the number of houses visited. So when we take that and we plug in our numbers, y over x, we're going to say, okay, that's going to be 4 pieces of candy, and we're going to visit 2 houses. Now, this division bar or fraction bar, actually we read that as a per. So when we come over to our actual fraction or ratio that we've rewritten with our numbers, we're going to say 4 pieces of candy per 2 houses. Now, that might sound a little strange to you because we can simplify 4 to 2. It actually we can take it down to unit rate, and when we do that, we're going to divide both 4 and 2 by the factor they have in common, which is 2. And we can simplify that to 2 over 1. Now remember, when we read that fraction bar, we're going to say per. So we're going to start with our numerator. So we're going to say 2 per 1 houses. So 2 pieces of candy per house or per 1 house. However that sounds best to you, it's both mathematically correct, but most people leave out the word 1 because it's per house. You make the assumption it's automatically 1. So let's take a look at what a graph would look if it's in a proportional relationship. Remember, proportional relationships, you must go through the origin or start at the origin, and it must be a straight line. Now, if we haven't gone trick-or-treating yet, we haven't gone to any houses, we haven't collected any candy, so that's our origin. 0, 0. So you'll notice I still have my other fraction or my other ratio to create my fraction. So I'm going to put both up here. So 4 over 2 or 2 over 1 from my first example. And now we're going to do our 0, 0. Now remember that division line means per, so 0 houses or 0 pieces of candy per 0 house. Okay, we must have that, and that means we haven't gotten started yet. So let's continue. You'll notice that this is in a proportional relationship because it is in a straight line. So what that means is any number or any point on that line represents a relationship. So if we take a look, and we're going to put a dot here, this is our 1, 2, so that represents for every 2 houses, or for every 2 pieces of candy, I get it from 1 house. Or I can reverse it and say for every 1 house, I get 2 pieces of candy. This is our proportional, this is our K, our unit rate, and it is also our constant of proportionality. Okay, so the points on a graph can mean multiple things. You just have to remember, okay, what's my label, my X and Y, and how can I use that? So let's take a look at another one. We all know the story of the rabbit or the hare and the tortoise, or the rabbit and the turtle, however you want to say that. And you'll notice I have 2 points here. The first point is 0, 0. That's my origin. Notice I have a straight line, or what looks like a straight line, so until I can prove it otherwise, I'm going to assume it is. So at point 0, 0, this is going to be the start of my race. For this particular example is for the tortoise. Now you'll notice here's my ordered pair, 3, 12. So I'm going to go ahead and put it in my constant of proportionality fraction. So I'm going to say 12 on top, 3 on the bottom, or my numerator and denominator. So look on your axes to tell you what each of those mean. So the 12 is going to be my distance that the tortoise traveled, and the 3 is going to be my time. Now, you don't want to say distance per time. You really want to use the units that they're talking about. So my distance in units is going to be feet, and my time is going to be minutes. So when I say 12, I'm going to use the label feet, and when I say 3, I'm going to use the label minutes. Remember that fraction bar means per, so I'm going to say 12 feet per 3 minutes. Now that still sounds kind of funny because it's not in unit rate. So if we look, we know that the factors of 12 are 1, 12, 2, 6, 3, and 4, and 3 only has the factors of 1 and 3, so the common factor that I can simplify by is 3. So this will actually give me 4. This will give me 1. When my denominator is 1, that's going to be my unit rate. So I can say 4 feet per 1 minute, or per minute, whichever sounds correct to you. Okay, so the tortoise is actually traveling 4 feet per minute, which for a tortoise I think is kind of fast. But let's go on. Notice this is a graph of the hare, and you'll see that it's not in a proportional relationship. It does start up 0, 0 because this is the start of my race. But you're going to notice this line right here. It has a constant speed, and that constant speed is 0 because it's not making any movement. So this is when our hare is at rest. He's not progressing any further in the race. And then you'll notice at minute 3, he probably sees the hair and goes, oh my goodness, I gotta catch up. And then he takes off again. All right. So when we look at these points, 0, 0, remember that's our starting. We haven't done anything yet. And right here, our ordered pair is 1, 8. So that tells me that the constant of proportionality, at least for this particular point for the hair, is 8/1. 1's in my denominator, so I know that's my unit rate. So the hair is traveling, remember I'm using my units, not distance and time. The hair is traveling 8 feet per minute. And if we go back to the tortoise is traveling 4 feet per minute. So the hair is actually twice as fast as the tortoise, as we would expect. But then between 1 and 3 minutes, the hair is at rest, and then he takes off again. And you'll notice here, our ordered pair would be 4:16. So let's check and make sure if he's going still at the same speed. So 16/4, that can be simplified. Common factors 4, so that's going to be 4/1. So he's now at that point traveling 4 feet per minute. So he's actually slowed down from his original speed that he started with. Okay, so let's take another look. Now we're going to compare these two, because when we graph, normally we just don't use a graph and look at a line. We compare two graphs together. So we're going to compare our tortoise and our hare. Now you'll notice that at 4:16, at coordinate 4:16, the tortoise and the hare are at the same point in the race. So that's probably what you see at the picture right there, is the hare has caught up with the tortoise, and they're trying to decide, and they're trying to figure out, okay, who's going to win the race. So we can tell how fast each is going by figuring out the unit rate, looking at the points on a graph. We can determine whether they start, what their beginning is, what their constant speed is, whether they continued at a constant speed or, like the hare, decided to take a nap, and at any point in time at the same place, are they still dead head to head or equal. So let's take a quick review. What do points on a graph really mean? Well, we first have to look at the quadrant in which they come from. For right now, we're just going to worry about the first quadrant, because both of our quantities are going to be positive. But if you look at the second graph, where we actually have a line, we're actually going to be looking for what is the relationship between the x and y axis. So remember, our constant proportionality is actually going to tell us that relationship. We need to look at our axes titles. Depending on what those titles are, if they're generic and in parentheses it has a unit, it's going to sound better if you use those units. So for this particular graph, it's going to be feet per minute. Any point on that line, and it's going to be easier for you to do right now if you choose the intersection where the graph is to determine those points. That is going to help you determine the relationship. Always remember to try to simplify to unit rate. If you can, it's going to make the most sense. That concludes our lesson for today. I really like that you joined me today, and remember to continue to practice on what graphs really mean and what those points represent. And it's been my pleasure for having you. My name's Mary Jo Fender, and have a great week, and I'll see you next week.
Hello, my name is Marcelina Lirius, and welcome to Math Monday. Today we're going to focus on this standard in Algebra 2, A2, BF, A3, which is describe the effects of transformations algebraically and graphically, create vertical and horizontal translations, vertical and horizontal reflections, and dilations, namely expansion and compression for a variety of functions. Before we start, please be ready with your notebook and your pen. Okay. So for this standard, we will focus also on the two unwrapped expectations. They are describe the effects of transformations graphically using the terms such as horizontal and vertical, stretch, the expansion or shrink, which is compression. We're talking also about translations and dilations. The second is describe the effects of the transformations algebraically using A, H, and K given an equation of the form f of x equals A times the quantity x minus h plus k, or given other forms of the functions. So in this case, we're actually looking at a parent function. Let's say f of x is equal to x to the power n. So when n is 1, we have a linear function. When n is 2, we have a quadratic function, 3 cubic, and so on. Now what happens if we change the parameters and transform this into the form a times the quantity, or f of x is equal to a times the quantity x minus h to the power n plus k. So what will now be the effect of this a, h, and k parameters on the graphs of functions? So let's review some of the vocabulary words. When we talk about translations, we're talking about sliding an object. In this case, we have the graph here of a parabola. So for horizontal translation, we're actually looking at the movement of the graph from left to right. Okay, from left to right, you slide it along the x-axis. And when we talk about vertical translation, we are actually moving the graph of the function upwards or downwards. Then if we look at this function, f of x or y is equal to a times the quantity x minus h squared plus k, which of these values here affect the translation or the movement of the graph? Then when we talk about reflection, we're talking about flipping, okay? You flip the object or the graph of the function across the y-axis or, okay, across the x-axis. So we now have our vertical translation or reflection. You flip the object across the x-axis, and for horizontal reflection, you flip the object across the y-axis. Then we'll look at which of these parameters will affect the transformation. Then we now have dilations. So when we talk about dilations, we're talking about compression or shrink. You compress the graph, or the graph moves closer to the y-axis. And when we talk about expansion, we're talking about the stretch. Okay, that means it widens, the graph widens or it moves away from the y-axis. Which of these parameters will affect the transformation or dilation? Will it shrink, or what affects, or which value will now change the graph or expand or shrink the graph? Okay. We will start with our parent graph. Again, this is a parabola. So if we have our f of x is equal to x squared, okay? This is a parabola with vertex at the origin, whose coordinates are 0, 0. And notice here on the left side, I use Desmos graphing calculator. So this is now our original graph transformed, okay, x squared. So you now have a, h, and k here. So our value for a is 1. In this case, we have h is 0, k is 0. So we are going to change the values of a, h, and k and figure out what transformation occurs. Okay, this is our parent function again. So let's look at these two graphs and let's look at the parameters. So when I change the value of a from 1, okay, to 4, so in this case, a is equal to 4. Notice that the graph, compared to the parent function here, the graph shrinks. Okay, it shrinks and moves closer to the y-axis. Okay, it becomes narrower. And on the second graph, when a is 0.1, okay, it's smaller, and it's a value between 0 and 1, it's a decimal. Here, 0.01, notice what happens to the graph. Okay, the graph is expanded, or there's a stretch, or the graph widens. So I'll stop here and process the information. Okay, when a is 4, we have a shrink. When a is smaller, it expands. The graph expands. Okay. In this case, both values are positive. Now, when we change the value of a, okay, a here, still 1, and we're going to change the value here, okay, a is 1, and on the second graph, again, we also have our h and k 0 in both graphs, but the difference is that on the first graph, a is 1, and on the second graph, a is -1. What conclusion can you arrive at when we change the value from positive to negative? So a equals 1. Okay, the graph opens upward. And when a is negative, the graph opens downward. So that is a vertical reflection. Okay, next. Let's move on to horizontal translations. Which of these values? So let's start with the parent function. Again, you have this y equals x squared. And you now change the value. A is still 1, h is 0, k is 0. This time, we're going to change just the value of h, okay? We have h is k, but our k is still, h is 4 and k is 0. H is 4, so notice that from 0, 0, from here, our graph was moved to the right. Okay, so you now have x minus 4, you now have the coordinates of the vertex. Look at the coordinates. This is now moved to 4, 0. Okay. And when our x, on the second graph here on the right, here, notice the difference. This is h is 4, and here h equals -3. So h equals -3. Notice the coordinates here. It's -3 and 0. It's a movement to the left. It's a slide, horizontal translation. This is affected by the value of h, okay? It's the value of h that affects this movement. Slide h, okay? Take note of that. Then when we talk about vertical translations, we're talking about the movement of the graph up or down. So if we have the parent graph y equals x squared, again, our a is 1, we put our h 0 and k 0. We will compare these two graphs here. So in the first graph, okay, again, you have a 0, k 0, but we change the value of k. In this case, k is equal to 3. So the transformation, if you know how from 0, 0, when you change the value of k to 3, the vertex now is at the point 0 and 3. Okay, And on the last graph here, we change our value. Again, or your h is still 0, but your k is -4. You compare this. This is at 0, 0. Now, this is at the point 0, -4. So it's actually the value of k which affects the transformation. And also, notice the change in the coordinates of the vertex, 0, 0 to 0, 3, 0, -4. So again, this vertical translation, when we change the value of k, it changes also the value of, it moves the graph up or down. Okay, take down some notes before we move on to the to graphing this using Desmos calculator. So now using Desmos calculator, we're going to summarize all these transformations by changing the value of the parameters. So earlier we said the value of A affects the, we're talking about dilation. Either it stretches or shrinks the graph, or also it moves or it reflects the graph upwards or downwards, okay? So here, I'll just press A here is equal to 1. But if we change the value of A, it moves, okay? Shrinks up or down. Widens or narrows or widens if you move it. So this is how it changes. So if you make it bigger towards +10 here, then going back, it becomes smaller and smaller until at this time, when it's negative, it now reflects downwards. So in this case, notice the graph here, A, the value of here is -3.5. It's negative, so it's downwards. Then, so when we change the value of H, we take our A constant. We're not changing the width or nor reflecting it across the x-axis. Let's change the value of H. In this case, when your H is positive, it moves to the right, so H, so that means H. Then it moves to the left when it's negative. Okay. Then, what's the effect of changing the value of K? So I move the K. Notice it's a movement upwards or downwards. Okay. So for your practice, I want you to Google Desmos graphing calculator and just click on, look for the parabolas in vertex form. Then you can just play around and just change the values of A, the value of H, then the value of K. So that concludes our lesson for today, and I hope to see you next week.